Deep in the cold vacuum of space, something absolutely terrifying is happening right now that NASA doesn't want you to know about. And if you're not subscribed yet, hit that notification bell because what I'm about to tell you will change everything. You thought you knew about our solar system forever. Scientists at NASA's Jet Propulsion Laboratory are working around the clock in complete panic mode after detecting something that should be impossible: a massive rogue planet that has somehow entered the outer edges of our solar system without any warning. This isn't some distant theoretical object that astronomers debate about in academic papers. This is a real, massive world that's currently barreling through space in a trajectory that has every single planetary scientist on Earth losing sleep at night. The most terrifying part isn't just that this rogue planet exists, but that it's moving in a way that defies everything we know about celestial mechanics, and NASA's emergency response teams are scrambling to understand what this means for every single person on Earth. If you think you understand how our solar system works, prepare to have your mind completely blown, because what's happening right now is rewriting the textbooks of astronomy in real time. And the implications are more frightening than any science fiction movie ever imagined. Leave a comment below telling me what you think could happen next, because honestly, even the world's top scientists are completely baffled by what they're seeing through their telescopes right now. The first sign that something extraordinarily dangerous was afoot came from a completely unexpected source. During a routine nighttime observation at the Palomar Observatory in California, astronomer Dr. Sarah Chun was analyzing data from the most recent astronomical survey when she noticed an anomaly that made her blood run cold. A small speck of light was moving through the star field in a way that simply shouldn't be possible. Unlike typical asteroids and comets, which follow predictable orbits, this object was moving in a straight line through interstellar space, cutting directly through the established planetary orbits like a cosmic bullet fired by an unknown force. The planet was discovered using gravitational lensing, where the planet passed in front of a star, distorting its light and revealing its presence. TESS finds its first rogue planet, but this case was different, much more disturbing. Dr. Chun immediately alerted his colleagues at NASA's Center for Near-Earth Object Studies, and within hours, all the world's major telescopes were trained on that specific region of the sky. What they discovered was so terrifying that the initial data was classified as highly classified for more than 72 hours. This wasn't just another rogue asteroid or distant comet. It was a full-fledged planet, estimated to be between 5 and 10 times Earth's mass, wandering alone through the cosmos without being gravitationally bound to any star. Recent research by scientists at NASA and Osaka University suggests that rogue planets' worlds drifting through space without being bound to a star may be more common in the Milky Way than planets contained within star systems. What made this discovery particularly terrifying was its speed and trajectory. It was moving directly toward our inner solar system. NASA's emergency response team was immediately summoned, with orbital dynamics experts summoned from their homes. In the middle of the night, Dr. Michael Rodriguez, director of the Near-Earth Object Program, would later describe those first moments as the most tense of my 30-year career. Initial computer simulations showed scenarios ranging from the merely disturbing to the completely catastrophic. The rogue planet, quickly given the temporary designation RX-2025, was moving at a speed of approximately 26 kilometers per second, far faster than any object previously detected in our solar system. Its current trajectory will place it in the vicinity of Jupiter's orbit within 18 months, a time frame that caused even the most experienced scientists to begin questioning whether there would be enough time to develop any kind of contingency plan. The physical characteristics of RX-2025 were equally alarming. Spectroscopic observations reveal that it was a rocky giant with a dense, toxic atmosphere composed primarily of carbon dioxide and sulfur compounds. Its surface, perpetually frozen due to the absence of a host star, radiated only the residual heat of its original formation, a ghostly glow that made it nearly invisible against the stellar background. Discovered in October 2013 using direct imaging, PSOJ 318.5 to 22 belongs to a special class of planets called rogue or free-floating. Wandering alone in the galaxy, they do not orbit a parent star. These rogue planets glow faintly from the heat of their formation. However, RX-2025 was significantly larger and closer than any previously detected rogue planet, making it an unprecedented threat. NASA's emergency communications protocol was activated for the first time in the agency's history for a planetary threat. Encrypted calls began to be made to presidents, prime ministers, and leaders of space agencies around the world. The European Space Agency, Russia's Roscosmos, China's CNSA, and dozens of other astronomical organizations were alerted to the developing situation. What worried scientists most was not just the planet itself, but the gravitational effect it could have on other celestial bodies as it passed through the solar system. Preliminary mathematical models suggested that RX-2025 could potentially disrupt the orbits of asteroids in the main belt, sending thousands of them on unpredictable trajectories that could pose additional risks to Earth. The origin of RX-2025 remained a complete mystery, further terrifying scientists. Rogue planets that drift through interstellar space independently of any star were known to exist, but one had never been detected actively approaching our solar system. Initial theories suggested it might have been ejected from its parent solar system by a violent gravitational interaction, possibly during the formation of its star system billions of years ago. Other, more disturbing hypotheses propose that it might be a survivor of a star system destroyed by a supernova or other catastrophic cosmic event. RX-2025's abnormal velocity suggested it had been accelerated by some massive gravitational force, possibly during a close approach to a stellar black hole or neutron star. Orbital calculations became increasingly alarming as more data was collected. RX-2025 wasn't simply passing through our solar system. Its trajectory showed signs of being slightly deflected by the collective gravity of our sun and the gas giant planets. This meant that instead of a quick, clean pass, the rogue planet could potentially be captured in a highly elliptical orbit around our sun, permanently becoming the 9th planet in our solar system. The prospect of a massive rogue planet taking a permanent residence in our solar system created a terrifying scenario that no scientist had ever seriously considered before. The implications for the orbital stability of all the other planets, including Earth, were simply terrifying to contemplate. Meanwhile, in the corridors of NASA, emergency meetings were taking place around the clock. Teams of planetary scientists, aerospace engineers, and communications specialists were working in shifts to develop response protocols for an event never anticipated in any procedure manual. The agency was faced with the challenge of not only monitoring and predicting RX-2025's behavior, but also deciding when and how to inform the public about a discovery that could cause global panic. Dr. Lisa Thompson, Associate Director of NASA's Planetary Science Division, spent sleepless nights coordinating global observation efforts and trying to establish communication protocols with other government agencies about the national security implications of this unprecedented astronomical discovery. An object observed to have moved in the time between its image by the IRA and Akari surveys in 1983 and 2006, respectively, could have been Planet 9. But RX-2025 was completely different, much closer, and posing an immediate threat. Early computer simulations of RX-2025's gravitational impact on our solar system produced results ranging from mildly disruptive to completely catastrophic. In the best-case scenario, the rogue planet would pass quickly through the outer region of our solar system, causing only minor perturbations in the orbits of the outer planets and possibly sending some long-period comets toward the inner solar system. In the worst-case scenario, RX-2025 could capture Pluto and other Kuiper Belt objects, dragging them into chaotic orbits that would eventually send them crashing into the inner planets. The world's most advanced detection technology was immediately directed to studying this cosmic interloper. The James Webb Space Telescope was reprogrammed to observe RX 2025 continuously, providing detailed spectroscopic data on its atmospheric composition and surface characteristics. Ground-based telescopes around the world, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, were coordinated in an unprecedented global observation campaign. Every pixel of collected data was analyzed by supercomputers running complex gravitational models, attempting to accurately predict where RX 2025 would be at each moment in the next 5 years. The results of these analyses were so varied and uncertain that they created more questions than answers, further heightening anxiety in the global scientific community. The most disturbing aspect of the entire situation was the complete unpredictability of RX 2025's future behavior. Unlike comets and asteroids, which follow well-established and predictable orbits, a rogue planet represents a new category of cosmic threat. Its significant mass meant it could gravitationally influence other objects at distances far greater than anything scientists had previously considered. Preliminary models suggested that even during its closest approach, RX 2025 could slightly affect Earth's orbit, potentially altering the length of our years by fractions of a second and causing subtle but measurable changes in our global climate. Over decades, the implications for the search for extraterrestrial life were also profound and terrifying. If RX 2025 had indeed wandered interstellar space for billions of years, there is a theoretical possibility that it could carry microorganisms or other life forms from its original solar system. The prospect of biological contamination from a source completely external to our solar system posed a new type of risk that had never been seriously considered by planetary protection protocols. Teams of astrobiologists were secretly convened to develop protocols to address the possibility that RX 2025 could introduce alien life forms into our solar system, even if only in the form of fossilized microorganisms in its rocky interior. Meanwhile, the general public remained completely unaware of the cosmic drama unfolding overhead. The decision to keep RX 2025 classified was made at the highest government levels, amid concerns that premature disclosure of an approaching rogue planet could cause unnecessary panic before scientists could fully assess the threat. However, leaks began to surface in the amateur astronomy community, with independent observers noticing unusual activity from professional telescopes and strange patterns in the observing schedules of major observatories. Online astronomy forums began to buzz with speculation about a possible significant discovery, forcing NASA to accelerate its public disclosure plans. The international response to the RX 2025 discovery revealed both cooperation and tensions within the global scientific community. While data was being shared freely among space agencies, questions over discovery ownership, naming rights, and control of the public narrative began to create diplomatic friction. China expressed concerns about being excluded from early planning meetings, while Russia insisted that its space telescopes should have priority access to certain observation windows. These political tensions threatened to complicate the coordinated scientific efforts needed to fully understand the threat posed by RX 2025, creating a situation where international cooperation had never been more critical, but also more difficult to achieve. The psychological effects on the scientific community itself were profound and unexpected. Many astronomers reported having nightmares about apocalyptic scenarios involving RX 2025, while others became obsessed with orbital calculations, checking and rechecking their mathematical models for flaws or inaccuracies. Dr. Robert Chun, a senior planetary scientist at the California Institute of Technology, developed what his colleagues described as orbital anxiety, a constant worry that his calculations might be wrong, and that RX 2025 might pose an even greater threat than initially calculated. The psychological pressure of carrying knowledge about a potential planetary threat while being forced to keep it secret, was taking its toll on some of the world's top scientists. Tracking technology was rapidly expanded to monitor RX 2025 continuously. A global network of telescopes was established to ensure 24-hour observation, with tracking stations strategically positioned around the world to ensure the rogue planet never left their sight. Specialized sensors capable of detecting RX 2025's faint infrared emissions were quickly developed and deployed, allowing scientists to monitor not only its position, but also changes in its surface temperature that could indicate internal geological activity. The financial investment in this monitoring operation was astronomically high, but it was considered absolutely essential for planetary safety. Increasingly sophisticated simulation models were developed to predict RX 2025's future behavior. Supercomputers at universities and government laboratories around the world were dedicated exclusively to running millions of different simulations, each exploring small variations in known orbital parameters. The results of these simulations created a terrifying probability distribution, while most scenarios showed RX 2025 passing through our solar system without causing direct catastrophic damage. A significant percentage of the models predicted gravitational perturbations that could destabilize the orbits of asteroids or even smaller moons, potentially sending them on collision trajectories with inner planets, including Earth. The most frightening aspect of the entire situation was that RX 2025 represented an entirely new type of cosmic threat for which humanity had no preparation or experience. Unlike asteroids or comets, which follow predictable trajectories and can be tracked years or decades in advance, a rogue planet can appear seemingly out of nowhere and fundamentally alter the dynamics of an entire solar system. The discovery of RX 2025 forced scientists to confront the frightening reality that our solar system is not the stable, predictable environment we have always assumed. It is, instead, part of a dynamic and sometimes violent galaxy where unpredictable cosmic events can occur without warning. As RX 2025 continues its eerily silent journey toward the heart of our solar system, one thing becomes terrifyingly clear. We are witnessing an event that will redefine our understanding of our place in the cosmos. Over the next 18 months, as this massive planetary interloper approaches, each day will bring new discoveries, new fears, and new questions about what exactly it means to live in a universe where entire planets can appear from the cosmic void like gravitational ghosts, forever altering the delicate celestial balance that has allowed life to flourish on Earth for billions of years.